We can see that the code is ready to run. So now let's head back to our lecture and recap what we have learned before proceeding further. So as we have seen, there are many differences between these two languages. To begin with, we don't even have the print statement as part of the default functions that are built into C. We have to specially include it using this #include stdio.h syntax. The printf statement, as we have seen, doesn't include the new line by default. And you notice that I did put \n for these two statements, but I forgot to do it for these statements. So you would have to remember that when you make those changes in the code. Next, we have seen that the entry point to a C program is not line 1 as it is in a Python program. It is the main function. And that main function must return the integer 0. This is the value that gets printed when you do echo $? After running your C program. If you change this value to a 1, then your echo $? Will return the value 1. But by convention, we will return the value 0 to indicate that our program completed successfully. Also remember that when we write a function in Python, we specify the return type afterwards using this type hint syntax, but in C you have to indicate the return type beforehand. Something similar applies to variables. You must specify the type of that variable. So this syntax is saying that x is declared as an integer, and you can't reattach this to an object of a different type. Ampersand of x is actually the location in memory where this integer value is stored. As I said, C doesn't provide a function called id of x, but ampersand of x is an approximation. That location in memory, it turns out in C, is mutable. And as we shall see, that has implications for the code that we're about to execute. Now this statement on line 3 is actually doing two things. Some people break it up into two statements like this. The first statement, int x semicolon, is declaring the variable x, but it is not initializing its value. And the second statement is actually initializing its value to this large integer. By the way, notice that this // operator, which is the floor division operator in Python, is actually a comment in C. So this / in C is like our hash symbol in Python. It ignores everything from that point on until the end of the line. It turns out there is no floor division operator in C. Now, as far as possible, I would like you to do this declaration and initialization in a single statement, not in two different statements. This is an old style of C programming, and most people prefer this more modern style of C programming. By the way, this idea of declaring a variable has no parallel in Python. In Python, you don't declare a variable and then assign it. A variable in Python can only come into existence when you assign it to some object that already exists. But in C, you can declare this variable just by itself. In Python tutor, it shows this visualization like this. It says there is this x, and it puts a little question mark over here to remind you that that variable is currently uninitialized, meaning there is a location in memory, but we don't yet have a value in there. Now that's not strictly true. Whenever you have some location in memory, there will be some value at that location. There is no such thing as an empty location in memory. So this question mark is just Python tutor trying to remind us that we don't know the value over there. Then when we actually do this assignment statement, that location will get a value. Now the next statement here, x times equals 3, this is actually going to multiply that integer by 3, just like in Python. But a very, very important difference is that in C, integers have finite precision. In Python Tutor, the version of C that is executing uses 32-bit integers. And what does that mean? It means there are only 2 to the power 32 possible representable integers in C. Now 2 to the power 32, as we have seen in an earlier lecture, is roughly 4 billion. About half of those values are negative and the remaining are non-negative. This means that the largest representable 32-bit int in C is roughly 2 billion. And what is it that we're doing here? This number is about 1.2 billion. When we multiply it with 3, we get something like 3.7 billion. And that number is not representable. So what I'm going to show you now is executing the original Python code and executing the modified C program, and let us observe the difference in these executions on Python Tutor.